The topic of discussion is thermochemistry, and the subtopic is heat and work done. So basically, there are two fundamental ways of transferring energy to or from a system, and these are heat and work. हीट और वर्क के ज़रिए हम सिस्टम से हीट निकाल भी सकते हैं और उसके अंदर एंटर भी कर सकते हैं. Let's see in detail what is heat. Heat is not a property of system. It's therefore not a state function. क्योंकि हीट एक सिस्टम की प्रॉपर्टी नहीं है, सो हम इसे स्टेट फंक्शन में क्लासिफाई नहीं करते. It is defined as the quantity of energy that flows across the boundary of a system during a change in its state due to difference in temperature between the system and the surroundings. एनर्जी की वो टाइप जो एक सिस्टम से दूसरे सिस्टम में जस्ट टेम्परेचर डिफरेंस की वजह से ट्रांसफ़र होती है, उसे हम हीट कहते हैं. It's either system or surroundings, or it's either two systems. Heat evolved or absorbed by the system is represented by Q. Let's see how heat energy is involved in a chemical reaction. Here is a system and its surroundings. System में we have beaker and the chemical reaction occurring in. उसके बाद हीट ट्रांसफर की बेस पे हम रिएक्शंस को दो टाइप्स में डिवाइड करते हैं, either endothermic or exothermic. Endothermic are those reactions in which energy moves from the surroundings into the system. Surrounding से system heat energy को absorb कर लेता है. While in exothermic reactions, energy moves from the system into the surroundings. So system जो है वो energy evolve करता है, जो surroundings का temperature जो है वो raise कर जाता है. Exothermic में, जबकि endothermic में क्योंकि वो surrounding से temperature को हीट एनर्जी को एब्जॉर्ब करता है, तो जो सराउंडिंग का टेम्परेचर है वो ड्रॉप कर जाता है. Here we have a practice MCQ. A system absorbs 100 kilojoule heat and performs 50 kilojoule of work on the surroundings. The increase in the internal energy is, and the options are 50 kilojoule, 100 kilojoule, 150 kilojoules, 5000 kilojoules, and the correct option is 50 kilojoules. You can easily get the answer by putting the values in the equation for internal energy, or first law of thermodynamics. So the other way of transferring heat was work. Let's see how we define work. It is defined as the product of force and displacement or distance. And the mathematical expression is W is equals to F cross D. F is force while D is displacement or distance. It is measured in joules. Here is the mathematical formula. W equals to F into D. In the previous slide, we have said that work is force into displacement. While in chemistry, we deal with the pressure volume work. Let's see how. In thermochemistry, we usually encounter pressure volume work. For example, expansion can occur when a gas is evolved during a chemical reaction. एक chemical reaction हुआ और उसके दौरान एक gas evolve हुई, जिसकी वजह से जो volume था वो increase हो गया. So work done is given by W equals to minus P into delta V. P is pressure while delta V is the change in the volume. Here you can see in this image कि यहाँ पे जो initial volume था वो यहाँ तक था. उसके बाद जब reaction proceed हुआ और उसका जो volume है वो यहाँ तक चला गया. So delta V, there is a change in the volume, यानी कि gas expand हुई है. So वो जो उसने distance cover किया उसको हमने delta V का नाम दिया, और जो force थी उसको हमने pressure के साथ substitute कर दिया. And minus sign is because कि work done is done by the system सो जिसकी वजह से जो वर्क डन है वो हमारे पास नेगेटिव आएगा. So this slide is basically the repetition of the previous slide. In pressure volume work, force becomes pressure and distance becomes volume change. P is external pressure and delta V is the change in volume. And the most important thing, work is not a state function. Previous slide में हमने force को pressure से substitute किया था और distance covered को volume change से substitute कर दिया था. So work done would be P into delta V. So area under the graph would be equal to the work done. Just like force into distance equals to work done. Here are the means by which we can transfer energy into and out of the system. So basically हम heat को system पे enter भी कर सकते हैं और heat को remove भी कर सकते हैं. Heat source अगर हम system में introduce करवाएंगे तो हम heat energy add कर रहे हैं और अगर हम वही heat source remove कर देंगे तो हम यानी कि heat को भी remove कर देंगे. अगर हम pressure apply कर रहे हैं system पे so we are doing work on the system और अगर वही pressure system release कर रहा है तो work would be done by the system. In this slide we will see the sign conventions. So अगर हम system पे काम कर रहे हैं तो work done would be positive. Similarly अगर हम heat enter कर रहे हैं तो जो sign आएगा वो positive आएगा और अगर वही work done system कर रहा है तो हम उसके साथ जो sign use करेंगे वो negative का करेंगे और अगर हम heat remove कर रहे हैं system से तो भी वो negative होगी. Work done on the system and heat supplied to the system would be positive and work done by the system और अगर हम heat remove कर रहे हैं तो वो दोनों signs होंगे वो negative के साथ आएंगे. Let's discuss another question. The heat of reaction depends on temperature of the reactants, physical states of the reactants and products, both, path of the reaction, and the correct option is both. So this was all about the lecture. I hope you have understood it well and thank you so much.